Okay, let's get the show on the road. Getting started a little bit late here after the previous ones. How many people are here? Quite a few. Okay, so you're all here for testing, right? In the right place. Today we're talking about testing with Spring, AOT, GraalVM, and JUnit 5. So who writes tests? Hopefully everyone. Who writes tests actually with Spring, like Spring integration tests? Good people. Has anyone ever written a test and run it in a native image? Few people. Is anyone, who else is using a native image, GraalVM native image? Just a few. Okay, so there'll be some new information for a lot of you, but I'm talking about more than just that. Standard disclaimer here. My name is Sam Brannen, as you've probably already figured out. I'm a staff software engineer at VMware. I've been a Java developer for over 20 years. Core Spring framework committer since 2007, and a core committer for JUnit 5 since 2015 when we started JUnit 5. So today what we're going to talk about is the most recent releases of JUnit. JUnit 5.9, 5.10 is coming out very soon. We just released M1. 5.11 will then be on the horizon. Spring 6.0 is already out. We're working on 6.1 now. And then I'll talk a bit about Spring AOT and GraalVM and how to test a little bit with those. And we'll have a demo at the end. So let's get started. So for JUnit 5, I've got the link up here. It's for 5.9.3. That includes all of the point releases since 5.9.0. You can check out all the detailed information there. Give you kind of a summary of the core features and biggest improvements there. So JUnit platform, right? You might know JUnit 5 is actually kind of three things, three projects. It's a platform. It's JUnit Jupiter, it's like the programming model, and JUnit Vintage is a support for running older stuff like JUnit 4 and JUnit 3. So on the platform and the core, we have XML report support from the new open test reporting format. We have a new iteration selector for when you're launching the platform itself, if you want to select a subset of a test or a container's iterations. And we have various improvements to the console launcher if you're using that in your applications or in your projects. So you can basically specify a single color palette, list the engines that are registered, and also the JUnit Suite engine, which was introduced in, I guess, 5.8. That's also now included in the standalone console launcher jar. Next up, talking about the more like the programming model, where how you actually write your tests in JUnit Jupiter 5.9. For the tempter annotation, we have support for configurable cleanup. So previously it was always mode, so it always got cleaned up. But if your test fails and you want to go check out the files that were created and see what went wrong, you can switch the mode to on success or never. There's also a new test instance pre-construct callback extension API, which is a counterpart to the existing one we had for pre-destroy. And another feature that you might find useful, I find very nice, that we now have reusable parameter resolution support for method invocations that extensions can use so they can have the same power basically that JUnit has to invoke your methods and pass parameters to them. And that's possible via the new executable invoker API, which you can access via the extension context. And that's used, for example, in the method source factory methods, which is the next feature. So now that we have this feature there, method source factory methods for parameterized tests. They used to not be able to accept any arguments, and now they can accept arguments, and those will be solved by parameter resolver, just like for your test methods or your for each methods and stuff like that. And in addition, after we introduce the feature, we introduce a new syntax to allow you to disambiguate between local factory methods. If they have the same name, you can basically specify the parameter list as well. Some more features as well. For the timeout annotation, you can now configure the thread mode. Inferred is kind of like just picking up the default you have globally, or you can explicitly set it to same thread or separate thread, and that just affects how the test is run and how the timeout extension attempts to stop that thread or interrupt it when the timeout has been exceeded. For conditional support, for determining on what OS you want to run on, so enabled on OS and disabled on OS, they've been there for a while, but they have new features. We now have support for selecting the OS architecture, so maybe like ARM architecture if you want to specify that, in addition to specifying the OS. And we also allow you to specify now FreeBSD or OpenBSD as the OS. And for native image, so GraalVM, deciding if you want to test or test class to run within a native image or not. We have new annotations for that at enabled in native image and at disabled in native image. And if you're writing your own custom assertions and you like the style and the format that we have in JUnit Jupiter for how we build up the messages, we now have a builder that you can use to come up with the same formatting for your own custom assertions. That's it for 5.9. Now 5.10, we just released 5.10 M1 last Saturday, so it's less than a week. So hot off the presses, we encourage you to try it out and give us feedback, and I'll run through some of the major features we just put out to Maven Central. So on the platform itself, we promoted several APIs from experimental status to stable, which is good for everybody. We've introduced built-in support for stack trace pruning to hide the internal details of JUnit, so when your test fails and you have the exception stack trace, it will show less JUnit internals now. We encourage you to try that out. If something doesn't work the way you expect, please let us know. This is an experimental feature, but it's turned on by default, but you can turn it off. For the console launcher, we have some new commands there. You can get the test feed details mode, or you can just run in discover mode instead of actually executing the test, just to see what it would run if it were to run all the tests. And something also similar, there's a new dry run mode for test execution if you want to basically test your own extensions to the platform without running an entire test suite. There's also a new launcher interceptor, but that's geared more towards tools and IDEs. In addition, if anyone's writing their own test engine, it's a rather more advanced topic, but within JUnit Jupiter, we've always had support for basically like a data store that's hierarchical for extensions, and we've extracted that into a namespace hierarchical store that can be used by other projects. Another theme that we are addressing, custom class loader arrangements. We don't have full support across the board everywhere, but we have made a lot of improvements in various places. For example, in reflection support, if you're using that class, the try to load class method now accepts a custom class loader. Similarly, with the find method support, it used to resolve the parameter types from their strings using the default class loader, and now it will use the class loader of the class you pass in, which makes sense. So it's going to find the parameters using the same class loader as the class that the method exists in. Similarly, we have some additional selectors, class selector, nested class selector, method selector, and nested method selector. Those accept custom class loaders now. And one of the use cases that's used a lot in is something like running in the OSGI framework, but you might have some other custom class loader arrangements where this would be applicable to you as well. In terms of the program model, back to JUnit Jupiter. Similarly there, we've also promoted a lot of the APIs to stable. For repeated tests, you might have used that annotation before. Sometimes you want to use repeated tests just to see if something is flaky, to see if it's failing. And in the past, it would just keep running, and if it started failing, it would just run over how many times you told to, and maybe fail 100 times. But now you can just set a threshold and say, like, stop running after the first failure, or stop running after the third or fourth failure, something like that. So it's just a little convenience there. For @Tempter, we now have a new SPI you can implement if you want to, called Tempter Factory, that allows you to control how the temp directories are created, and more importantly, it allows you to control the file system that's used. So one use case for this is to use it in in-memory file system instead of writing to the default native file system in your OS. Following along on this idea of providing support for custom class loader arrangements, we also have that in some of the annotations and support in JUnit Jupiter itself. So the @enabled if, disabled if, and method source annotations, those all take fully qualified method names, which have the fully qualified classes in them. And in order to load those classes, we now use the class loader of your test. So it's more likely to see those types. And similarly for parameterized tests, if you have an argument coming in as a string that's the name of a class and needs to be converted to a class, we now use the declaring class of the parameterized test method to resolve that. So basically just better support in OSGI and other custom class loader arrangements. If you're using parallel execution, just so we have some new options to configure that, and you can check out the documentation for more details. And if you're writing your own argument converters with parameterized tests, we have two new base classes, annotation-based base classes for arguments provider and the argument converter interfaces. So that's it for 5.10. Now we're going to be a little bit more forward-looking with JUnit 5.11. You see this link here is to the milestone page, so that basically shows what the current roadmap is, but you can always follow along and participate in the discussions there. So right now what we have planned, some of the things are already in the works. We have before suite and after suite annotations coming in for basically lifecycle methods for your suite. that you can use with the JUnit platform suite engine. Some of that code's already there and will be finalized for 5.11. We're also going to take the notion of custom class load arrangements further, and into JUnit Jupiter, we'd like to introduce a dedicated extension API so that people can provide their own class loader to affect how JUnit Jupiter tests are executed. Next up, if you're familiar with parameterized tests, we have all types of different types of argument sources. You might know them, such as CSV source or CSV file source or method source or enum source and stuff like that. And one that we have coming up is going to be field source, and I'll show you an example of that. And then the next big feature, probably be the biggest feature in JUnit 5.11, will be support for what we call container templates. That's analogous to the existing support for test templates. We'll have a new API behind that. But what you might know test templates better as repeated test is a type of test template, and a parameterized test is a type of a test template. So one of the main goals for us, obviously, is then to support something called parameterized container, and this is effectively going to be parameterized test classes. So right now with JUnit Jupiter, you can have a parameterized test method, but you can't parameterize the whole test class, and that's what this new feature is going to allow us to do. So for field source, let's say, for example, you have some utility class somewhere in your code base with a field that's maybe an array or a list or a collection or something like that, and you'd like to use that as the input into your parameterized test. The way you'll be able to do that in the future is create your parameterized test like normal, but instead of having like a method source or something else, you'll be able to say @field source and then specify the name of the method if it's just a local method, or a fully qualified, field, the name of the field, or the fully qualified field name if it's a field in a different class. So we assume here that this utils class is an example package, and then this fruits field would be read, and that would be converted into a stream and used as the arguments for the parameterized test. For the parameterized test classes, I have a couple examples to give you an idea of what it might look like, and you can also comment on the issues on GitHub if you want to get involved there. So first example would be field injection, annotating your class with @parameterized container, specifying your argument source. In this case, we have CSV source, inline CSV, and then specifying fields. And then we have to tell JUnit which fields correlate to which of the parameters that are coming in from the parameterization. And we would just do that probably based on position. So parameter 0, parameter 1, et cetera. In this case, you'd get apple and 1 for the first permutation, and then banana and 2. And then just write your tests as normal, accessing those fields. So of course you would have multiple test methods, otherwise it wouldn't make sense to have parameterized test class. You would rather do that as parameterized test method. Another example, construction injection. Some people prefer that. That would also be supported. So you'd write the class basically the same way, but then you could have immutable private final fields and have a constructor that accepts those, and then JUnit would invoke this constructor with the parameterized arguments, and then write your tests like normal. So while we were brainstorming on this in the JUnit team, I was typing in these examples, and I thought, this looks like a lot of boilerplate code, right? How could we do that better? Anyone have any ideas? Records. We can use records. Might be kind of abusing it, but you can have parameterized records. That's our idea. So basically write it the same way you would before, parameterized container, and then just define your record class, right? So that's going to have your constructor for you, and then JUnit would be able to inject that with the parameterized values as well. So that's one thing we're looking forward to being able to support in JUnit 5.11. So that's it for the whirlwind tour of what's new in JUnit over the past year. Now we're going to talk about new testing features in Spring 6.0 and 6.1. So 6.0 to X, I say X because we introduced a lot in 6.0 GA, but we've introduced more over time up through 6.09 and probably going forward as well. One of the key things that we did, not necessarily explicitly for testing, but as a core feature in the framework, we've always had support for class path scanning, especially with class path star : resource prefix. You always use that for class path scanning, and now we have support for module path scanning if you're doing everything in a modular way since Java 9 or higher. And one thing that's useful for in testing is if you're using Maven, Maven Surefire is going to automatically create like a patched test module for your code, and then the class path scanning won't find everything, but with the module path scanning in place, it will find everything in your test patch module and your normal module. In terms of Servlet API, so for the mocks and mock MVC, We now have a baseline of 6.0, so you have to compile and run your tests against Servlet API 6, but at runtime, don't worry, you can still deploy against Servlet 5.0, and that will work. So it just might require some change in configuration in your build for your tests using Servlet mocks. In terms of mock MVC, we've also added support for assertions against cookie attributes. And if you've ever written any test classes, integration tests with test-ng or used any of the JUnit 4 base classes, they used to have a hard-coded list or set of test execution listeners, and now we've changed the way that's done so that you can benefit from the default registration of test execution listeners, meaning that you'll get them picked up from the class path, whether they're from Spring Boot or Spring Security or any other third-party library that's registering their own listeners. Another small thing that's quite nice, it's less noisy now in the console. So when you're running your test, we have less information output at info mode, a little bit more at debug mode, and then you can get everything you want still at trace mode, but by default you're going to have more concise output and not so much noise when you run your test, especially when you run like a Spring Boot test, integration test, for example. Another kind of inside or internal, almost internal SPI, we have a new application context failure processor. You could use this for your own purposes if you have a need to kind of track what's going on when your application contexts don't load for your tests. But more importantly, you'll probably see the benefit of this because Spring Boot relies on this to give you a nice detailed error analysis when your tests fail, just like when your application fails to load with the Spring Boot application. And last, but of course, definitely not least, a lot of the work, pretty much most of the work I did for Spring 6.0 testing support was the ahead of time testing support and the support for running your tests in a GraalVM native image. Now 6.1, you've learned that the conference already is on the horizon, right? It's released later this year, but we've already started some work on the testing support and we already have some ideas as well. One thing that's already in place that you'll have in the 6.1 M1 milestone is support for using the @record application events feature, and it will record async events now. So you can record events from another thread other than the main test thread, the thread that your test is running in. And you can also use some utilities like a utility. You might have seen that before. It's a nice unit testing kind of library for testing concurrent things, and it'll allow you to use that as well. One thing to point out is that there are some limitations in JUnit Jupiter. So for example, if you have test instances per class mode and you're running things in parallel, then that won't work, but we'll detect that and we throw an exception if we see that that's the case. Some other small enhancements coming, so the character encoding can be set to null or cleared out for mock HTTP servlet response. And you can now set the remote address when using mock MVC via the mock HTTP servlet request builder in case you have a need to set that. Another feature that should be coming in as well, you might have had situations where you had something wrong with your application context and your test configuration, and you run your test suite, and it fails a whole bunch of times, and you have to wait for all the failures. And one thing we'd like to do there is improve that so that if we detect that it's already failed, this configuration has already failed, we won't be attempting it again. So just make your test suite fail faster. And depending on how the work in JUnit Jupiter turns out with this parameterized container support, so these parameterized test classes, there might be potential or a need to provide some explicit support or integration with that, but we'll just have to see how that develops. So that's it for the overview and the core features. Now we're going to dive in a bit more into AOT and native images. You've already heard a lot about that probably over the past year, some of it at this conference as well. Also in the keynote, there were some nice summaries and some nice examples and demos. So I'll just kind of give you an angle on testing with relation to that. So what are AOT and GraalVM? You probably already know, but AOT in summary is ahead of time optimizations, happens in the build process and used at runtime. In GraalVM, we're going to focus on the native image support, right? So we have the support for compiling our application, like our Spring Boot application, into an OS-specific binary. with some closed world assumptions, and maybe requiring some additional configuration for runtime hints and things like that. So the details are in the reference documentation, but in summary, the Spring AOT, those are optimizations that are meant to inspect your application context and configuration in the environment at build time, and then store that somewhere, right? And then basically apply that at runtime. So the core infrastructure is all in Spring Framework since 6.0, but AOT support has been implemented across the portfolio in many ways, also native image support. And the build tools are in Spring Boot. And then these Spring AOT optimizations are going to be used. They could be used on the JVM, which I'll show you. But primarily the focus so far has been to use these optimizations when running in a GraalVM native image. So the testing support is there. It's documented as well, but I'll give you some highlights and some tips here. Basically, at its core, what we do is we have build time detection of the Spring integration tests. So when we're trying to figure out what kind of tests you have, we're going to scan the test class path and look for things that look like integration tests for Spring. We have explicit support for JUnit Jupiter and JUnit 4, and implicit support for things like TestNG and other frameworks if they're using the Spring testing annotations or the Spring Boot testing annotations and stuff like that. So once we find all the classes, what we then do is that we process them, and we're going to have to load all the application contexts for those, or figure out how we're going to load them for those tests, figure out which ones are unique, right? If you're reusing the same application context configuration, we don't want to process it multiple times, but then we are going to process them for AOT, have some AOT artifacts generated, and then at runtime, when you run your test in what we call AOT mode, we're then going to use those AOT optimized application contexts. So one thing that's different in the testing area and in the normal production scenario, you have one application context for your whole application, right? But in your test suite, you probably have many different application contexts if you're using like different configuration or different slices in Spring Boot and stuff like that. So for the testing scenario, we have to actually optimize multiple application contexts. Now, to get all that working, and then the build tools, you might have heard as well, there's GraalVM native build tools. Here's the link to their documentation. What that came out of is a collaboration between the Spring team, Oracle Labs, and Micronaut. We've been working with them for several years. Basically, you can build native images with your build. You can run your tests in the native image on the JUnit platform, and they have plugins for Gradle and Maven, and the Spring Boot plugins actually incorporate those into your applications when you create an application from start.spring.io. Now, runtime hints, you might have heard of that before. Sometimes in a native image, you have to specify that you want to use reflection or you want to have particular resources available, stuff like that. You might need some specific to test as well. Luckily, we've done a lot of that for you. It's just built in the test context framework in Spring Test and Spring Boot as well. But there might be times when you need to add something more. So if you need something that's specific to your test classes, you can implement the test runtime hints registrar. Otherwise, you can implement the standard Spring runtime hints registrar, and you could register that globally in the AOT factories file, or you could just annotate your test class directly with @import runtime hints, and I'll show you an example of that in a bit. And the other option, I think we saw this in the keynote as well, you can just annotate your classes, in this case your test classes, with @reflective or @register reflection for binding, and you can check out the standard documentation for those annotations and what they mean. Now, when would you have to implement something really custom? Two scenarios probably, two that we support out of the box. The first would be is if you have your own custom context loader you've written, it would now need to implement the AOT context loader. That would allow it to participate in AOT build time processing as well as AOT runtime execution. But don't worry, these are all of the context loaders from the framework itself and from Spring Boot. They already implement AOT context loader, so it should just be that most of your testing scenarios will work out of the box. Another scenario might be is if you've written your own test execution listener that needs to register some kind of special hints. Maybe it works with some custom resource files, and you need to make sure those are available in a native image. You could implement AOT test execution listener now to participate in the AOT processing and register those hints. And if you'd like to see an example, we have one concrete one in Spring Test itself. You can check out the implementation of the SQL scripts test execution listener, and that basically registers hints for all of your SQL scripts that you register via or you use via @SQL in your tests. So just a bit of a summary on the options you have for JUnit support within native images. Mentioned before, JUnit itself provides these two annotations to decide if the test should run in a native image or not. We have the native build tools for building our actual tests into a native image and then running them in the native image for JUnit Jupiter and JUnit 4. And we have the Spring Boot build tools. So starting with Spring Boot 3.0, Gradle and Maven supported, and they integrate directly with the native build tools. So once we have created our project, how can we actually run our tests in a native image? This is all documented in the Spring Boot reference guide, but just as a recap, for Maven, you run with the native test profile test, and for Gradle, you have the native test task. And you should definitely do this before you deploy to production, right? You should run your tests in the native image to at least have an idea. If your tests aren't passing the native image, then it might be likely that your application doesn't work in the native image either. But this is a timely process you've probably seen or you've experienced yourself. It can take a while to build a native image. It's not really a great developer experience yet, so you probably don't want to do this multiple times a day, definitely not hundreds of times a day. But you should at least then consider running tests in AOT mode on the JVM first, and that's what I'm going to talk a bit about here. So this is a disclaimer. Testing in AOT mode on the JVM, it's not yet ready for prime time. I say that it's there, it works, but the developer experience isn't there yet. We're going to be spending more time over the coming months or the coming year or so to make sure that that works out better. Also, as we allow people to more easily to run their applications in AOT mode on the JVM, we'd also like to make it easier to run tests in AOT mode on the JVM or within your IDE. So this does require some manual setup currently. Yeah, it's possible with both Maven and Gradle, and today I'm just going to show you how to do it with Maven to give you an idea of what's currently possible. So why would this be useful? It might be nice to know that your tests are running in AOT mode on the JVM before trying it with the native image, or maybe if you have some things that aren't working because of AOT complications, then you can run them much faster in your IDE or run them much faster without running them or compiling a native image and then running the tests from there. And you can also debug them within your IDE, and I'm going to show you an example of that. So here's a mini tutorial on how to do that. What you first need to do is you need to tell Spring Boot build tools to generate the AOT test sources. So process your test classes, look at the application context, generate the AOT artifacts, and put them somewhere for you. So we do that with Maven with clean test. It's kind of a two-step process. We run the tests, and then we run the process test AOT part of the build, and that will output something, and I'll show you where that is and what that looks like. Then once you've done that, if you'd like to from the command line, you can just run your tests like you normally would, but specify spring.aot.enable equals true as a system property, and that will run your tests in AOT mode. Then within your IDE, if you want to work with these generated artifacts, what you need to do is you need to add these generated sources as a test source folder to your project. For Maven, that's going to be under target Spring AOT test sources, and I'll show you an example of that or what it looks like. And then you're going to need to set up the output directory somewhere. You can set it to the same as your test code or to another output directory if you wish for your IDE. And then one final note on that is if you have cases in your application where Spring is using CGlib to dynamically create a subclass of one of your classes, maybe of a configuration class, your Spring Boot application class, then what Spring will do is it will create or use CGlib to create the class, and it will store the class file in the file system. And you would need to additionally add that those pre-compiled classes to the output class path in the IDE if you need those. But an alternative to work around that sometimes is just to set proxy bean methods equals false, either on an at configuration class or as I'll show you in your Spring Boot application annotation. That also works for the main Spring Boot configuration. So then testing in AOT mode. As I mentioned before, command line, you just provide the Spring AOT enabled equals true, and the same is true in your IDE once you have it set up. You might have to configure your test runtime or test configuration to set that JVM property, but if you do that, it will tell the testing framework, aha, now we're running in AOT mode. Even though we're not in a native image, we can still run in AOT mode and use the AOT optimized application context and artifacts and stuff like that. And that's really it. Sounds kind of simple, but as mentioned, there's a lot of manual steps you have to do to get that working. But once you're done, you should see output like the following: loading application context for AOT runtime, or starting AOT processed service tests, if that's the name of your test class. You'll also see that in the command line when you run your test in the native image, but you see these same AOT prompts and log statements in your IDE when you're running without native image, but in AOT mode. So debugging, once you have that all set up, what you can do is you can find the mapping from your test class to the AOT optimized application context. Each one of these is a context initializer, so an application context initializer. And we have a file that I'll show you how to find that. AOT test context initializers generated, those are generated mappings, and then you can look up the mapping from your test class to the initializer that's going to be used for it in AOT mode. So for example, the service test that I'll show you later, it has a mapping as test context 01. That's just an enumerated list starting with 1, and then application context initializer. So once you have that, you could go open that up, and you could set breakpoints in there, and then run your test in AOT mode with the debugger turned on, and you can debug basically application context initialization in AOT mode for your tests. And that's it. Okay, so I'm going to show some of these things, and I don't know if we'll be able to get any questions in. We'll see. So I have a project here. Started with start.spring.io, just added some web support. It's a relatively or very, very simplistic application. And it's a Spring Boot application. As I mentioned, here I've set it up with some proxy bean methods equals false, so it's not going to have a CGLib proxy for this class. Then I have a very simple service interface, basically like Hello World. Generate greeting, simple implementation, saying hello Spring.io. It's an @service component there, and we have a REST controller that's going to use that service. And if you do a GET request to /hello, it'll return that message. So that shouldn't be too excited or too enthralling. That's not the point. We just basically want to show simple ways to have a Spring Boot application and be able to run it in AOT mode. So we have a test class using Spring Boot test, getting the greeting service auto-wired in, and just making sure that it has the production values. And then I made a copy of it. The reason I did that is I want to show you that if you have multiple test classes that have the same context configuration, there's only going to be one AOT optimized application context for that same set of configuration. So this copy of service test really looks exactly the same. If I run it, we see here it's running, it passes. And the same for web. I have a controller test one here. And it's a web MVC test slice. It's using a local configuration for the service that's going to say hola, because we're in Barcelona. And it's just going to make sure if we do a request to /hello, it's going to end up saying hola, and hopefully that passes as well. So yes, that passes very quickly. No problems there. Now, one thing you do note here is this import runtime hints. That was not something I had planned, but it appears that a runtime hint is missing, and I'll be reporting this to the Spring Boot team. But when I originally ran this test in a native image, what happened was I got an exception that was like this, saying some reflection information was missing, and I created this runtime hints registrar, and for this special Spring Boot internal class, I made sure that the methods can be invoked with reflection. And then on the test class itself, I've used this standard annotation from the Spring Context module, import runtime hints, specifying that, and then my tests run in the native image as well. But again, you can use this for your own purposes. If you have to register some reflection hints for your test code that Spring doesn't pick up on, or Spring Boot doesn't pick up on, you can register that yourself. So what does this actually look like? I'm not going to take the time to build the native images here. I've already done that. I have a little archived folder here, and we have some Spring IO will actually run the application. Just want to show you what it looks like. Start it up pretty fast here, 0.033 seconds. Oops. Here we go. If I hit enter, yes, it's returning hello Spring IO. If I shut it down and reload, then we see that it's not there. So that's just proof that the native application works. And similarly, the tests, I've also compiled them or ran the Maven command to run the test in the native image. And what that does is that actually builds a native image that includes all of your test classes and the JUnit platform, right? And puts it all in one thing, and then it runs the JUnit platform inside the native image, so then it's running your JUnit Jupiter test in the platform in a native image. And we see that's in there. Native test is the name of the file it creates, or the name of the binary. If we run that, your tests run blazingly fast. Milliseconds. So that's pretty cool to see that that works. But again, what I want to focus on now is to show you how to run it in AOT mode without actually compiling the native image. Just to point one thing out, if you see here starting AOT process, that's what I was saying before. That's how you know that the AOT optimized version of your test is actually running. That has to be the case in the native image, but we also want to make sure that's the case when we're debugging in AOT mode in a minute. So going back to what I was saying in the slides about what happens. So this is Maven, we have target. Let's see if I can, oops. Oh, that's not what we wanted. Let's see if we can make this bigger. Hopefully you can see that. So we're in target, and we have Spring AOT, which you wouldn't normally see, right, without the Spring Boot plugins. And if you go in there, we see we have the test, and we have sources. Now we have org, Spring Framework, and that's all the things from Spring Core and Spring Boot. You can look through those if you want. The one thing that would be interesting right now is to look at what's in the test part, right? So we have the test context, AOT, and this is this class I was talking about that has these mappings. So this is the mapping from your test class. You'll find a map here, and these are the 3 test classes I just showed you. And each one of them has a mapping to a particular initializer. And what I mentioned before as well, the service tests and the copy of service tests, they don't define different context configuration, different configuration classes or anything like that. So they actually end up pointing to the same logical application context. And then you see that they both have the same initializer. So that's what I was talking about earlier. And you'll need that to know which class to open to start the debugger if you want to look in there. Oops, how did that go? Where did it go? There we go, all right. And the other thing to note is that there's this other package, that's the one I picked for my example. Spring IO is the base package, and this is the service in web. And we'll see that in the service, I do have its copy of service class. And you can, if you want to look at it, you can see how the AOT stuff works, right? How it's figuring out which beans to create and how it's doing it all in an optimized way, combining all of your configuration into simpler, oftentimes functional variants. So the bean definitions, if you look in there, you see that's the production one. He's using the default greeting service. And if I were to look at that one with the controller test, oops, let's see. In web, in the bean definitions for that, we see that it has the greeting, where is the test one? Oops, keeps going the wrong way. It's using the test greeting service. So you can see how all this gets pulled together. Like we had an import statement, right? You might have some class path scanning, all these kind of things, but everything ends up being an optimized, AOT optimized application context, and you can set breakpoints in any of these things and debug any of this to make sure that it's working. But so the point is now that I've run, let's see, oops. This is the part I was talking about. If you run this, this will generate the sources, and hopefully I don't kill my demo, right? If I delete this folder and then come back here and run that, that should hopefully create all that stuff. All this AOT optimized application context, and we have them back. Yeah, so they're there. And then if you go to your IDE, what I was talking about is you can import that as a source folder. Here I have that added. target Spring AOT sources. I've set it up as a test folder. In Eclipse, you have to do that. And then we see all that code is here, and it all compiles. If it's not compiling, then something's wrong as well. So then you can go into any of these things and set a breakpoint. So let's go ahead and run one of the tests, see if we can get it to run in AOT mode. The copy of service tests is not set up like that. If I run that and look at the console, we'll see, don't see anything here about AOT, so it just ran in standard mode. And for the service tests, what I've done is I added this to the configuration. I can show you that. Well, if I click on it correctly, run configurations, JVM arguments, I have this here. Spring AOT enabled equals true, so now if I run that, what it's going to do is actually going to run in AOT mode, which is the same mode it's going to run inside of a native image. And now if we see that, we also see loading application context for AOT runtime for test class, and this is our test class. So we know it's actually using the AOT optimized code. And the other thing I wanted to point out is that we should be able to debug that as well, right? So, oops. Picking the one, so we want to do the service test context user 1. So that's the service test we were just running. And then we want to go down to org, Spring Framework, test, context AO2, right? So there's a generated we see in there. Which one is going to run the service tests is going to run this class here. And then we could go in there, and if we wanted to, we should be able to set a breakpoint and then go back to the actual tests. And if everything works, we'll end up in the debugger. Yeah, all right. So not very big, but the point is that once you're in here, you can step through the code and step into the internals, the AOT internals, and the normal Spring internals, and see what's going wrong if your application's not starting up correctly in AOT mode. And that's it for the demo. Does anyone have any questions? Yes, I don't know if we have a mic, but we can try it out. I think you have a mic there? Oh, she's got a mic for you.
I'm wondering if this is running inside a Docker or is running directly in your computer?
No, this is just on the computer. This has nothing to do with containers or anything like that. This is a straight JVM. I ran native image test, but I ran the native image compiler with a GraalVM compiler. But this is just using the JVM and standard IDE support for Java.
But if it's native, it makes sense to test it inside the Docker or image where you want to run it at the end.
Yes, for sure. But the native images, the tests, you would want to run them. If you're going to run them in Docker, then you would want to run them in the container. But you can also compile it, native image for your local platform and run them locally. But right, you do want to test eventually for your target platform. But that wasn't the goal I wanted to share today. I wanted to focus more on how you can do it with AOT locally without containers and without the native image.
Thank you.
Mm-hmm. Anyone else? No? Okay, well, if there are no questions, thank you for coming. Enjoy the rest of the conference. Enjoy Barcelona.